Hello everyone, welcome to another problem discussion on Leetcode, and this is problem 143, reorder list or reorder linked list, and this is one of the problems in blind 75 list. So let's go to the problem description. As the problem description says, we are given a linked list. As you can see, there are list nodes starting from index 0 up to index n. So say like n-1 linked nodes are there in the linked list. And then what we have to do is, as you can see, we have to reorder it. So we have to reorder it that the first node is L0, that is fine. So the L0, then this one gets linked to Ln, and then we get the second node L1 and second last node Ln-1, and then third node L2, and then third last node Ln-2. So we have to reorder it this way. Okay, so as the problem suggests, so basically, if this is the list, so the first node is going to be connected to the last node. The last node is going to be connected to the second node. The second node is now going to be connected to the second last node, right? So this is how you reorder it. So we have to solve this problem, and let's think how we can solve this problem. So let's break this problem into multiple things. So first, you can understand that if I want to reorder, first probably what I have to do is I have to have the list, right? So if I have the list, say, so that's the first step. So breaking the list into two halves, right? So two halves, right? And so this will look like this: 1, 2. This is null, and the other part will look like 3, 4. Right? Okay. Next part that we have to do is we have to reverse the second part. The second part will now look like 4, 3 if I reverse it, right? So it will look like this. So now we have these two parts. So we have this 1, 2. This is the first part, first half. And then we have the second part, right? We have the second part, which is 4, 3. After we have reversed it. Next, what we have to do is we have to merge these two things. So you see, first we have to delete this and make a new link to 4. And then from 4, we have to delete this and make a link to 2. And from 2, this one we have to delete and then make a link to 3. So that's it. So it will look like 1, 4, 2, 3. So that's our reordered list, right? Okay, so three things. First, we have to break it into two halves. And then, so this is step 1. Step 2 is we have to reverse the second part, right? And third, this is step 3. We have to merge, okay? So let's go step by step and to see how we can do it. Okay, so dividing into two halves. So first thing is like we can have like even number of nodes, or we can have odd number of nodes. Let's say we have 1, 2, 3, 4. This is even number of nodes, right? Or we can have, say, 1, 2, 3, 4, 5. Let's see how it works, how we can do it if they're like even or odd number of nodes. So we can use two pointers. One is slow pointer. So list node slow pointer, and then the second is a fast pointer. So this is a usual techniques. So the slow pointer moves one place. So say the slow pointer moves one place. When the slow pointer moves one place, the fast pointer moves two places. Okay, next time the slow pointer comes here, the fast pointer goes all the way to this. Okay, yep. And for the second one, if the slow pointer is here, the fast pointer is going to be here. Then the slow pointer moves here. The fast pointer is moving to this, right? Okay. And as you can see, we have to stop somewhere. That means if we try to move the slow pointer again to this, now the fast pointer is moving to something which is not possible because already we have reached null. There is nothing here. We have to stop somewhere. Okay, so let's see where actually we want to target. So the target is in the first, if there is even case, then that our target is find this middle node, right? And if it's say odd, then probably we can want to divide here. So this is our target. So either we want to divide here or we want to divide here. So in both of these cases, let's say, why don't we just stop, say when the slope pointer is say here. So we stop when the slope pointer is so here, and then we stop if the slope pointer is here. In both of these cases, we can return slow.next. All right. So this will be slow.next. And this is also going to be slow.next. Right. So let's see. If I want to stop when the slope pointer is here or the slope pointer is here, what do I have to do? So let's see if when the slope pointer is say here, when the slope pointer is here, where is the fast pointer? You see the fast pointer is here, right? That means we can say the fast dot next. So fast dot next is this, fast dot next is this. Now, okay, in the second case, you can see if the slope pointer is here, the fast pointer is first it comes here and then it comes here. So the fast pointer is here, right? So the fast pointer is here. And as you can see, the first fast dot next is null. So can we say that while either fast dot next is null, while for fast dot next is not null, and fast dot next is not null. Yes, and not null. Or let's make it like not null. So if these two cases are true, only then we move. So slow becomes slow.next and fast becomes fast. So fast moves like twice at a twice speed, right? Okay. Okay. So this is the thing. We have a slow pointer, we have a fast pointer, and then while the fast dot next is not equals to null, so this one stops, like this is fast dot next becomes null, so it stops here. So the slow is here now, right? For the even cases, you see this is the fast pointer now. Fast dot next is null, so it will stop, and now the slow is here. So in both of these cases, we return slow.next. So that is this red thing, right? So that's the beginning of the second list. Okay. So we got the beginning of the second list. And next what we do is we make sure that we cut off, like slow becomes a, okay, we can just make sure that slow dot next is equals to null. We make it null. Make sure that this is cut off. This is now in two different lists. Okay, so that's done. Having the making like dividing the list into two. So the next thing that we want to do is we want to reverse the list. Reverse the list. So say if we have a list like this, 3, 4, then say null. We want to reverse this, right? Okay. So to reverse this, we have to do a few things. First is we have to reverse the direction of the next. And obviously, this next is now going to be reversed in this direction, and this has to be a null. Okay, so how do we get a null? Let's put a null, call it previous, and this is our current node, right? Okay. And so we have to make a connection between the current and the previous, and make the previous the next of current. But for that, I have to delete this. But if I delete this, then I will be losing track of this. So let's do this. Instead of losing track, let's save this thing first. So temp equals to current dot next. So that way I am saving the temp here. Okay, so once this is saved, I'm safe. Now let's delete it and make current dot next, set it to previous. Okay, now current dot next is set to previous. Okay, so you see already one portion is done. This portion is still left. Okay. So next time I want to break this and make a new next to this, right? So the previous is going to be, this is going to be the new previous, and this is going to be the new current, right? Okay, so let's do this. So previous, the current is set to previous, and temp is set to current. So we got our new, current, and previous. Okay, so we repeat this thing again. Now you see current's next is set to temp, so this one becomes temp now, and then I delete this, and current's next is set to previous. Done. Okay, the current becomes the previous, so this one becomes the new previous, and the temp becomes the new current, right? Okay, but I'm already done, so I will run this while current not equals to null. Okay, so once I'm done, this is now the head of the new list, right? The previous, so I return previous. This is my second part. Like I'm done with reversing. Okay, so next I have to merge, right? Okay, so my initial list was like this: 1, say 2, 3, 4, 5. And then there was null. And then I had halved it. That means I had broken it here. Then I had reversed this. So this one now became 5, 4 null. And this part was 1, 2, 3. And say null. Okay. So now I have to merge these two, and then reordering is done. Okay, so for that, let's say we call this the first. The first is here, the second is here. Okay, so let's keep something called, so if I can actually make a link to this, right? Make the second as the next of first. But for that, I have to erase this, and then I will lose track of this. So first I have to save this again, right? So let's save this. Let's say temp1. So temp1 equals to first dot next. Done. Okay. And then I make the second as the first new next. Okay, so this is deleted and this is established. Okay. Okay. That's fine. Next time I have to make a new link between this and this, right? Okay. So how do I do that? So I have to, let's make this. So this one was temp1, right? So I make this temp1 as the new first. Done. Okay. Next, my target is, so this one is now the new first. My target is now creating a link there between this. So if I want to create this, first I have to erase this. So that means I have to save this. So let's keep something called temp2 is second dot next. Okay, so I save this in temp2. Now I can successfully delete this and set this. That means second dot next is set to first. Okay, and for the next time, this one is going to be, next time I have to create a link between this and this, right? So I have to make this second. So this is going to be this new second. So second is going to be temp2. Okay, so you see I have done this. Okay, and next time I repeat this thing again, temp1. So this one becomes temp1. This is going to be the first is next. Okay, and then first is next is set to second. So that means this one is going to be set to second. And then temp1 becomes the new first. So this one becomes the new first, right? And temp2 is now set to, so this one is going to be temp2, right? So this is going to be the set next to second. Seconds next is now set to first. This. And second is now, temp2 is now the new second. Okay. Now you see we have this 1, 5. Then we have from 5 we went to 2. From 2 we went to 4. From 4 we went to 3, right? And the second is now already in null. That means while, we'll keep on doing this while second is not equals to null. Okay, so until the second is not equals to null, we'll keep on doing this. So that's our merging, and that's it. So let's check the code. So we are given the linked list, and you see if the list is already null or it has only one node, there is no reordering thing, right? So in that case, what I do is I just return. I don't have to do anything. And then I have these finding the middle. So I have the slow pointer and the fast pointer. And as I had shown you, like I will keep run a while loop until the fast next is not equals to null, or fast.next is not equals to null. So the slow will move one place and the fast will move two places. Okay, and next the current node. So now I want to get to the beginning of the second part. That is going to be the slow.next, as I have shown you, right? Okay, and so this part, now I am going to reverse the second part. So I have the head of the second part, that is slow.next. I need a node previous. I start with null. I have shown you in the explanation. And I cut off the first list. That means flow.next, I cut it off, set it to null. So the first part is cut off. Okay, now until the current node is not equals to null, I just keep a temporary node to point to the next, make the previous as a current next, and then replace the current to with previous. So make the current node as the new previous and the temp node as a new current. So I'll keep on doing this until the current node is not equals to null. So this will reverse my second part. Okay, so now the first part, I know if I go back to the head, this will give me the first part because I had cut off the first part here, right? Okay, and if I go to the prev here, this is going to give me the head of the second part as I have shown you in the description, in the illustration. And then this is merging the two parts. So while the second is not equals to null, this is exactly what I just showed you, right? So I have a temp one, I will set it to the next of the first list, the first node, and then make a link between the first and the second node and reassign the temp one to the first node. Similarly, I will save the link to the next of the second in temp two, assign the first as the next of the second, and then reassign the temp2 into the second. So I will keep on doing this until the second node is not null. And finally, after doing this, so this is the third part, the merging part. After this, the merging is done and my reordering is done. So this is a little bit tricky, this problem, but this one actually solves three problems together. So there are problems where you have to find the middle of the list. Then there are problems, Leetcode problems where you have to uh, like reverse a list, and then there are problems where you have to merge two lists. So this is the combination of all those three problems. So this is a very nice exercise. So thanks for watching, and before I leave, I would suggest that you should do this problem yourself. That would be a really good practice. Otherwise, there are chances that you are going to make one once you try to execute the whole thing. Frankly, actually, this problem gave me some trouble. I had to just submit a few times before I was able to make it accepted. And this was my submission result. Okay, and as you see, this one was pretty fast. And final thing is, like, what is the order of this thing? So the first part was finding the middle, right? So this was order of n because both the pointers moved uh, from the beginning to the end at most. And then this was the second part where I reversed. So this is the half of the thing I did, right? I just reversed it. So it was actually order of n by 2 or something like this. And the third part was I did just reorder merging two lists. So both of the lists were n over 2 size. And I just changed, like rearranged the links n times. So this is also order of n. Right? So in total, you see we have like order of n plus order of n over 2 plus order of n. So the time complexity of the algorithm is going to be order of n. What is the space complexity? You see we didn't use any extra space. So we had just used these spaces 1, 2, and then 3, and some temporary nodes, right? So it's constant number, like 4 or 5 temporary nodes we used. So the space complexity is just constant. Whatever the size of the original list is, we just use these temporary nodes, like 4 or 5 of them. So that is the constant. So space complexity is constant, and time complexity is order of n.